So initial thickness is T1, the final thickness is T2, or we can say Tf. So T1 is initial thickness, T2 is final thickness, D is the diameter of roller. Roller is very large in diameter, usually 600 mm. T1 is initial thickness, is usually 30 mm. So as compared to the roller diameter, the size plate is very small. So don't go for my actual figure. Actual figure is this radius is very large. T2 is the final thickness. So it is reduced to around 20 mm or around 25 mm. So let's say 20 mm. So first term we introduce is called as draft. So draft is defined as D is a change in thickness, that is T1 minus T2. We assume here that B1 is same as B2. So there is no change in the width. That is assumption. We are assuming this one is constant, and if L1 is the length, original length, so this one is length of plate, L2 is the length of final product, then there is no change in the volume strength that we have seen yesterday, so volume will not going to change. So what is the cross section? Cross section is B multiplied by T1 multiplied by length L1 must equals to B multiplied by T2 multiplied by L2. So you see a B is constant, so we can say T1 is T1 multiplied by L1 must equals to T2 multiplied by L2. We have a strip like this, and we are reducing the strip to what? Final thickness equals to what? T2. And no external force is applied. There is a pure friction at this point. So here, first of all, this plate is pushed inside, and the friction will occur from this surface, and because of friction the plate is dragged. So at this point we have a friction. The contact start at point A. At point B we have a contact also. At point C the contact exit. So VR equal to pi dn by 1000 is velocity of roller in meters per minute, where n is the rotational speed of roller. So this one is speed of roller. Now both the rollers are made identical, because what are the forces is acting at this point and what are the forces are acting at this point. So all these forces can be resolved into horizontal and vertical component. The net force will act downward and the net force will act upward. To have a equilibrium of this one, the size of the two rollers must be same. If they are not equal, then either the upward force is more or the downward force is more. If the upward force is more, the plate will bend in the downward direction. So the plate will not be in a straight form, it will bending effect. And if the downward force is more, the plate will tend to bend in a upward direction. So if you do not want any type of bending, then the diameter of roller must be the identical. To avoid the bending of the strip, the velocity of both rollers must be the same. And if their diameters are same, then the rotational speed is also same. The diameters of roller must be same for making constant equilibrium. So net downward force must cancel with the net upward force. The velocity at this point is V0, and this velocity is constant up to point A. And the velocity of this part is V2 or Vf. And this velocity is from point C up to this point. So velocity continuously vary from V0 to V2. So here velocity of V2, that is the exit part, is larger as compared to velocity at point B, that is called as velocity of roller. And at point A your velocity equals to what? V0. So the point where the velocity of the strip is same as the velocity of roller, and that point is called the neutral point. So here B represents the neutral point. Similarly, we have one more neutral point on the bottom side also. So we have one neutral point at the top and one neutral point at the bottom. Now the velocity from A to B, velocity at A point is V0. Velocity at point B is VR. So VR is more as compared to V0. Because of this one, the strip is drawn inside because of friction. And afterwards, V2 is more than velocity at point B, that is neutral point. So strip is automatically dragged because of high velocity. So we don't want a friction from entire passage. We want just a friction for A to B portion. That's all. Once the strip will be entered, it automatically comes inside. So there is a slip. So there is a slip from A point to B point, that is called as, similar to backward slip, we have forward slip. At point C, velocity equals to what? V2. And at point B, velocity equals to VR. So V2 is more than VB, so we have forward slip. Is defined as velocity at point 2 minus velocity of roller divided by velocity of roller multiplied by 100%. Just remember here, every time is divided by VR. that is neutral point. So all velocity you have to compare with the neutral point. This one is also positive value as well as this one is also positive value. So if we compare this point ABC with the given figure, so up to A is the velocity equals to V0. So up to A velocity is constant is equals to V0. So this one is velocity V0. At point B we have a neutral point. At neutral point we have velocity equals to what? VR. So velocity increases to VR. So this value corresponds to VR. And from B the velocity again increases to point C. So velocity increases to point C. And later on the velocity is constant. So this one is velocity with respect to point ABC and this one is final velocity V2. Now because of this one, your entire zone is divided into two parts. I will call this one is zone 1 and I will call this one is zone 2. So this actually represents work velocity. So this axis represents work velocity. So your graph is varying from V0 to VR to V2 and then remain constant. So the first zone is called as lagging zone and the second zone is called as leading zone. Why it is called as lagging and leading? Because at this point your velocity is what? VR, which is more than V0. And this point is called as leading because this point is higher velocity as compared to previous point. So we have two zones, one is leading and one is lagging. And in the first figure you find here there is a plastic deformation taking place. So for A to B we required a very large forces. For A to B we required a very large forces. Now either you say forces or you say pressure. So pressure requirement will be different from A to B to C. This point is our neutral point. On y-axis we are marking a pressure. As far as the lagging zone is considered, the pressure is inversely proportional to slip. And in second case, the pressure is directly proportional to slip. So that is why we get the variation is something like this. First the pressure will rise, so we will start like this. It attained a peak value at this point and then the pressure will drop. So initially we have inverse relation and then we have direct relation. So maximum pressure will be approximately equal to at neutral point. Now do not remember the equation that I am giving you, P average. So P average is given by 2 by 3. Yesterday we got the value of sigma 0, sigma f is flow equation. So yesterday we got the flow equation equals to what? Flow curve is given by K into epsilon to the power N. What is N? Strain hardening. What is epsilon? True strain. So we are using manufacturing true strain, so every time we will not write epsilon T. And what is epsilon T? We are defined. So epsilon T we defined as ln of initial thickness divided by final thickness. K is called as the coefficient and N is called as strain hardening coefficient. This one is called as flow coefficient. So this one is our sigma f, that is the flow stress, multiplied by 1 plus mu multiplied by L divided by 4 into T m. So what is Tm? Is the mean thickness. What is mean thickness? Is T1 plus T2 divided by 2. Now you don't require this equation for GATE examination. They will directly give you the value of P average. So contact length is will denote by capital L. And what is exactly contact length? Is this length, that is this portion. So we want to find out this length. This one is called as contact length. But remember, don't go by this figure. This figure is very large diameter and you find here substantial arc here, but in fact it is almost a straight segment. So this length will approximate like this. That is called as contact length. So let call this one is point A. Let call this one is point C. Let we have a center here equals to C. Let join this point here C and let join A also. C with B. So what is this length? This length is same as L. This length is contact length. Then this length is same as R. Is it a radius of roller? A to C, radius of roller. C to B is radius of roller. So I will take out this portion outside. I will enlarge this portion. So this one is my point C. This one is A. This one is B point. This total length from here to here is R. This total length from here to here is R. And this one I am calling as contact length L. which is a very short circular arc, which I am approximating equals to what? A straight line. So this angle form, this is not a right angle triangle, remember this. This one is angle alpha. So alpha is called as bite angle. They always ask you a question on the contact length and bite angle. So angle formed by ACB. So this one is angle ACB is called as bite angle. So to solve this geometry, what I do is that I will take the help of right angle triangle. So let me define this length, and let's say this is additional point equals to D point, and let call this segment equals to the segment length equals to S. So let's say AD equal to what? S length. Now what about this length? Now this is the enlarged figure, remember. Now come to my original figure first. Is this total height equal to T1? Is this total height is T1? Is this height is T2? So is T1 minus T2 is the net change in length. Is that change in length is adjusted half on this side and half on this side. So is this is T1 minus T2 by 2, and this one is also T1 minus T2 by 2. By 2. Drop by 2 is T1 minus T2 divided by 2. Correct? If this one is D by 2, then is this length remaining from C to D? Is it R minus D by 2? What is length from C to B? R. What is the length from B to D? D by 2. So what is the length from C to D? R minus D by 2. D is called as drop. Find out length L. We can come to this L by considering the triangle ADB. And this one is what? A right angle triangle. To find out this value, I know this dimension, but I don't know S dimension. So to find out S, first I will take the right angle triangle of ADC, because this one is also equals to what? 90. So I can apply Pythagoras and I can solve for S. So let's consider triangle. So we have triangle A, D and C. Is it right angle triangle? A, D, C is right angle triangle. So we can apply Pythagoras. So as per Pythagoras, we have R square, hypotenuse square, adjacent square is S square, and this opposite is R minus D by 2. Let's expand this. So we have S square plus A minus B square is R square minus 2 times R into D by 2. Correct? Plus square of this term is D square by 4. 2 and 2 cancel. This 2 and this 2 is cancelled. So what we get? S square. This one is right hand side is also R square. So we have R square equals to, this one is S square, next step, this one is R square. Is it correct? And this one is minus is what? RD plus D square by 4. So this time this R square will cancel out with this R square. And can we solve for S square? So what is the value of S square? So value of S square is RD minus D square by 4. Next calculation I required S square only because I am again going to apply for right angle triangle. So now we consider triangle ADB, that is the bottom right angle triangle. For the bottom right angle triangle, L is the hypotenuse. So we have L square, we have S square plus D by 2 whole square. But what is S square? S square we have just got is RD minus D square by 4. And expansion of this term is what? Plus D square by 4. So this D square by 4 and this D square by 4 is cancel out. And do you have equation for contact length? L equals to under root of RD. So remember the equation of contact length. L is given by under root of R. What is R? The diameter of roller. And what is D? The draft. Is that okay? So draft is given by T1 minus T2, and we have contact length equal to under root of RD. So remember this equation also. Bite angle will again visit the same thing, that is this one. We got an equation of S square. So let's consider triangle ACD. So triangle ACD. What is tan alpha? Tan alpha is, that is RD minus D square by 4. But this one is under root side. This length is S. Triangle ACD. What is tan alpha? S. And what is S? Under root of RD minus D square by 4 divided by this length. So this length is what? R minus D by 2. Correct? Now, is the value of draft is very small as compared to radius? As the value of radius of the roller this one is very large quantity as compared to what? Drop. So if you are adding a very small number into a very large number, the effect is negligible. It's a 595. Correct? And you are making a square of this and then dividing by 4. So is it again a very small number? So what we do is that we will neglect the effect of this quantity and this quantity. Is that okay? So right, neglecting the effect of d square by 4 and d by 2. So we will make it equal to what? 0. But this is not a correct idea. But the angle is very small, so you can do this. So what do you get? Tan alpha equals to. Now this time I write under root. Now this one is RD and this is outside the under root. When it comes inside, does it become R square? Agree? So one of the R will cancel. And is the final equation is under root of d by R.